Hi there, welcome back. This is probably going to be a fairly short video. It's a continuation of the series on the Telefunken Dacapo 9. And the reason I'm doing this is in response to a couple of requests that I've got, which is to see what the response curve is with these tone shaping circuits. Now, strangely enough, this radio does not have a tone control, as in a normal tone control, okay? What they count on is on these preset tone shaping buttons. Now this one here says bass, this one says speech, this one says intimate, and this one says jazz. Now it's pretty accurate to guess that that does set the tone for different environments depending on what you're looking for, but I wanted to see just how flexible this is, not just in what it sounds like, but what it looks like on a response curve. And we can use a little device that I built recently, which is the interface to the sound card. We can put that on the Visual Analyser software and see what we get. But first of all, there's something else I wanted to do. I noticed distortion coming up on this when I put the volume up at a certain level. I'm not sure that that's the highest level that we can get. And I've had this question raised quite often by myself mostly in restoring these radios. The question being, how much does the age of the power tube affect the power that you can actually get, the clean power that you can get from this radio? And fortunately, we can now answer that question. I've got a couple of brand new EL84s. I only need one, so I can replace that one there. And I've also got a new old stock EABC80, which has never been used, according to the vendor. And I've got to tell you, I've looked at this tube, it looks pretty new. I bought a few actually. So we've got ourselves some new tubes, and we can actually compare to what we're going to get from that, and then try out with these guys and see what we're going to get from these. Okay. Now, bear in mind, that is a, what is it? I don't even remember what brand it is, but it's not a JJ. This is a JJ tube, so the brand of tube could make a difference as well. But what I'm going to do is I'm going to put this on and look on the scope. We're going to see at 1 kilohertz, we'll just use the 1 kilohertz signal, see what level we get with the old tubes and then with the new tubes. The next thing I want to do is I'm going to actually do a sweep from 20 kilohertz to 20 hertz to 20 kilohertz on these various settings, and we can compare one to the other using that interface for the Visual Analyser software that I've got on my PC. Okay, let's start. What do we need to do here? Well, we need to make sure that this volume control is set at its maximum. And the reason for that is because this volume control has got a tap-off point somewhere up the wiper, not sure exactly how far up. We don't want that loudness effect to come in. I want the sound to be as cleanly through as possible without the effects of the tone shaping on the psychological tone control or loudness control that they use on the volume control circuit. So the way to do this is I'm going to set an arbitrary level of the output waveform. I'll set that on the scope, and we're going to see what happens when we replace the tubes. I've got a 100 millivolts peak-to-peak sine wave coming out of a signal generator up there, and if I turn this up, it's not distorting, but I'm getting 1.48 volts. Is that it? RMS 1.48. What I'm going to do is I'm going to leave this on max, and I'm going to decrease the signal generator so that I can get, say, 1 volt peak to peak, rather 1 volt RMS. So if I look at the scope, either here or on the screen, I've got 1.48 volts, and I'm going to bring this down till I get exactly 1 volt. There we go, 1 volt. That's at 1 volt. I've got exactly 1 volt RMS on the output measuring the speakers. Now what I'm going to do is I've left that on for a while, and I'm now going to switch off and replace the tubes with the new ones. Let me switch it off over there. I'll start with replacing the EL84, so just the power tube, first of all, because that's probably the one that's going to give us the most effect, the most difference. One thing I can advise you, be careful when you remove this thing. It's bloody hot. Really, really hot. That's what heaters are for. Okay, so fitting that guy in, switch on. And we look at the screen. We've got this thing set exactly as it was, maximum volume. We had 1 volt RMS, and here we go. Not much difference, is there? 1.02, 1.04. Well, that's a bit of a disappointment. It just tells us that, well, I think it tells us that this tube was in perfect condition, the old one. 1.05. That is 4%, 4-5% difference, and it's in dB, you can't even bloody calculate that. It's almost nothing. Okay. So that tube change did not do much. Okay, let's try the other one. So again, I'm going to put the old one back. No reason to use the new one here. And this thing is still hot. Bloody hell. So we've got that one back. And we're going to remove this guy. This one I can probably touch. Yeah, it's not so hot. So that's the EABC 80. Remove this one. This thing is brand new. Looks good. So let's put that guy in there. Now remember, these are the only 2 tubes that affect the audio. This is the preamp. The triode is being used as a preamp. And the EL84 is obviously the power amp. So let's hit it again. See what happens on the scope. You've got to let it heat up a little bit. It's going up. Now that is a strange one. It's still heating up, but it's 900 millivolts, so it's lower. This triode is biased. Remember, the bias circuit's exactly the same as it was with the old one. So the bias that was set for the other one is biasing this one lower. That is not to say that the audio won't be better. Could be better, but it's certainly not giving us the same levels that the other one was, which is a bit of a strange one. Really strange. I think the other one just was accustomed to playing music more than this one is. So we've got 918, 920 millivolts. So 8%, whatever it is, below the other one. Okay, so that's obviously not giving us much of a difference. So I'll just put that back. Let me switch this off. And again, we can touch this because it's not so hot. And we can put this guy back. If it's good, why change it? Okay. All right, here we go. We've got it back. And let's see if it goes back up to 1 volt. Still climbing as it heats up, and it's going to get there. All right, so what have we seen? We've seen that the old tubes are actually giving us a higher level than the new ones. And we're back to just under 1 volt. It'll creep up. So we're back to what we were before, and that's a bit of a surprise. I always thought that these tubes, especially the power tube, if you change it, we'd get the amplitude up, but obviously that's not always the case. Certainly not in this case. What we've seen here is that the old tubes actually give us a high amplitude. This is amplitude, all right? There might be more distortion. There might be all sorts of stuff that the old tubes are suffering from that the new ones won't be. But as far as amplitude is concerned, those two are in perfect condition. Now I want to do something else. If you've seen a few of my past videos, you might recall that I built this little device. It's an interface for my oscilloscope software package. And the reason I built this is not because I needed an oscilloscope, but because I use Visual Analyser, which has a very, very good boat plot or frequency response curve plotter. And that's what I use it for. It helps me isolate the signal from the PC interface. And it's also got a 10:1 option here, divide by 10. I use it with a scope probe, an old scope probe, which also has divide by 10. So I can get a divide by 100 function on here and protect the PC scope from the signal. Now what I'm going to do here is I'm going to connect this to the speaker outputs. Make sure I get the polarity right, because the reference that the signal generator is using is the same as the reference that the scope is using for ground. I've set up the signal generator to create a sweep, and it's a logarithmic sweep starting at 20 Hertz going up to 20 kilohertz, and I've given it a 3-second time for the sweep, and the result is I can see it on the screen. Now I can increase the volume here. Actually, it is increased. Oh, this isn't set properly. Divide by 10 on. There we go. Okay, so I can see this, and I can actually stop this and do a peak hold so we can see the curve. Now I'm going to set that up, and let me show you what we're doing here. Now we've got bass on here. This is for extra bass. And if I put on the peak hold, let's select peak hold, spectrum, peak hold, okay, and that's what we get. So we let a few sweeps go by and see what happens. And here we can see it. Now what we're seeing here is a slight build up to the 100 Hertz, which is over here, flat, more or less flat, and then it starts coming down. And this is something you need to be, there's something you need to be aware of. This is actually reading the response of the speaker. It is not catching the effect of the electrostatic tweeters. For that, I would have to monitor at the anode, and I don't want to do that with this thing because there's high voltage there. I know this thing's separated, but it makes a lot of noise. So we're actually getting a sort of a response curve. It's not absolutely accurate, but it's not bad. Okay, so that is our base. Now, get our settings back, remove our peak hold, and let's put it on speech. So what do we get on speech? Back to peak hold, okay. All right, we can see the difference already. Give it another couple of sweeps. So speech is giving us a drop in the bass and lower mid-range, and then up here between 1K and 2K, up to 3K, you get the peak, and then of course it starts going down again. And as I said, probably from this point onwards, from about 4K onwards, you would probably have this thing tapering off less as the electrostatic tweeters come into effect. But clearly we can see that the bass and the lower mid-range, the full mid-range actually is reduced. Okay, next. Release our peak hold. Let's put it back to bass, which is flatter, and we'll put in intimate. Intimate, let's see what intimate's all about. Peak hold again, okay. All right, well, we can see what intimate is. Yeah, in intimate, you don't want any shouting, any screaming, any high frequencies. What we see here is a raising of the bass frequencies and certainly a fairly significant cutoff on the from the 1 kilohertz onwards. So all the treble frequencies are reduced. So I suppose you want sort of a warmish sound with very little treble. And of course here again the effect of the tweeters, the electrostatic tweeters would come in, but you'd still get quite a pronounced drop over here. Now we are going to do the same for the, what do we have here? We've got, this is jazz, okay? Back to peak hold. And with jazz, yeah, what we're seeing with jazz again is fairly flat here and then less pronounced cutoff on the tweeters. I would hazard a guess and say that the tweeters would take off from about here, from about 3K, 3 to 4K, and you'd probably get a fairly flat response all the way across. We'll never know because I'm not going to try that. But anyway, this is fairly interesting in that we can get an idea of what sort of response differences we get when we select these tonal presets. Now, as I said before, these things are fixed. There is no adjustable tone knob, but hey, that's not too bad. That's fine. When this thing is playing, we'll see what it sounds like with the tweeters in there. And I'm sure that it's going to have more than enough of the low end and the mids and the high end to satisfy us all. This was just a little experiment to see what the response curve was going to be like. And also, the one that surprised me, to see whether changing the valves, the tubes, for new ones would make a difference. And as we saw, it actually worked out worse. As I said, this could be just a little bit deceiving because it could be a situation where the distortion might be lower and everything else. But as far as amplitude is concerned, these valves are perfect. They are both original Telefunken tubes. Probably worth a hell of a lot more than the radio's worth right now. I'd like to put that on a valve tester one day. I don't actually have one because those things are huge and I don't really need one. But it would be interesting to see just how strong those valves are. They certainly seem to be working fine. So that's it for now. I want to thank you for sticking around. And if you've enjoyed that, click like, share, subscribe, and all that jazz. And I'll see you back soon for another video. Thanks for watching. Bye for now, and stay safe.